Hello, I am Meenakshi working as a assistant professor in EEE department, KSR College of Engineering. In this video, we are going to discuss about integrated circuit bus, that is I2C bus. I2C is a simple two-wire protocol with just two wires. It was developed by Philips in 1980 for its TV applications. Later, we use this bus for various embedded applications. It is a synchronous half duplex and serial protocol. This is the structure of the I2C bus. In this image, we have a single master and a single slave device. The data can be transferred between master and slave bus using I2C bus. There are two wires in this structure. First one is SDA, it means serial data line, and the second one is SCL, it means serial clock signal. Here the master sends clock signal to the slave, that's why it is a synchronous serial protocol, and then the data can be transferred between serial data line. Here single line is used for data transfer. That means the data can be transmitted and received through this single wire at a time. That's why it is called a half duplex protocol. In this slide, we have a single master and multi-slave system. Also, we transfer the data between master and slave devices using I2C bus by using serial data line and serial clock signal. In I2C bus, there are two signal wires used. The first one is serial clock signal, the second one is serial data line. I2C have one master and multi-slave system. Each device has its own unique address and then it is fixed by the hardware. Generally, master is a microcontroller unit. It can transmit as well as receive. Master only initiates the data transfer. Slaves, depending on the master, whether they are input or output devices. After receiving each byte, an acknowledgement signal is to be sent by the receiver IC to the sender IC. These are the data transfer process using I2C bus. Initially, the master sends the start signal to the slave. The second step is master sends the address of the slave to find the slave. Then we decide we have perform write or read operation, and then the acknowledgement signal is sent. After that, we transfer the data each byte by byte. At last, we send the stop signal. The first step is master send start condition and controls the clock signal. Second step is master send a unique 7-bit slave device address, and then master sends read or write bit, a 0 for slave receipt and 1 for slave transmit. Wait for as send an acknowledgement bit. Then we send or receive the data byte as 8 bits. Finally, send the acknowledgement bit. At last, we send the stop bit. This is the overall structure of the I2C bus. Here we have the single master and multi-slave devices. Master is usually a microcontroller and the slaves are peripheral devices. In this we have DAC, digital to analog converter, analog to digital converter, and LCD display. So the data can be transferred between this master device and then peripheral devices by using I2C bus. I2C bus has two wires. One is serial data line and the second one is serial clock line. Each slave device has unique own address. After sending or receiving the data, it sends an acknowledgement signal. These are the advantages of I2C bus. I2C requires only two wires for communication. It is easy to perform diagnosis and debugging. And then at disadvantages, the hardware complexity increases when number of master or slave devices are more in the circuit. It is a half duplex mode of communication. Here for data transferring, it has only one wire. That wire is used to transmit as well as receiving the data. Applications of I2C: RF tuners, video decoders and encoders, and audio processor. Thank you.